right? Because I tried doing something like this for the subsequent question that I'm going to present in front of you, and this did not work for that question for me, so I was thinking it won't work here too, but anyway, let's see. So the next question that we have is, given a binary tree, write a function to tell us if it is balanced or not. What is now? So we should just, so the function definition is Boolean, is balanced. I'll define what is balanced. Say root. So what is balanced is the difference between the left and the right subtrees can be at most 1.
0.
So it can be either 0 or 1. So that's the question that we have. So is this balanced?
Yeah.
Is it balanced now?
No.
So where are we losing the balanced property?
Yeah,
At this point itself we lose.
Left and right.
Right?
No, this is fine, but the
Here it's fine, yeah.
But
And
the
this
next
level,
node
right?
should go
Here,
there.
Here,
Yeah.
here at this
So the
point.
left tree is balanced, the right tree is balanced, but both of them are not balanced.
Yes.
Because the depth is different.
So this is balanced. And this tends itself to another question where you'll have to then figure out what is the height of the highest height in terms of, in a situation like this you should you should be able to give me the height of the balanced tree, which is with the highest height in an unbalanced tree like this. That it tends itself to another question, and that's something I found it pretty challenging for me to solve. Hopefully we can get to that, I don't know for today. But then, so use your knowledge of the height of the tree to write this function. To say whether it is balanced or no.
Recursively, iteratively, or doesn't matter?
Right now I have no constraints. I have solved it or I have thought of it recursively.
Recursively you can do. Right, maybe using a static. Can you use using a VFS? Okay.
Because return a height as well as true text, those are possible.
Actually, you don't have to return negative one, you can return negative one, yes, right? Actually, not yet. So you should fill the tree as you go. And make sure that there's at least one in every level. So fill the tree. This is null. Node, null. So which means that the depth of this is proper if there is at least one element in this and at least one element in this. Right? But if you have nothing here and you have one element here, that's okay.
This is not an element.
Yeah, which is fine. You can figure that out. You can figure that out. If I am trying to add a child to this side, when I have nothing added, nothing on this side, this half, then that is simplest as edge condition. It's not balanced. I'm trying to see if I can come up with a different algorithm.
You want to insert and come up with that.
Correct. If I, at the time of I know my left half, which is a Q1, right half, just Q1. Okay. If I have something in Q1 and I have a child and I have nothing in Q2,
But how do you track it?
or if the other way around, there is bad one.
Yeah, but you can't track that from here at this point.
It is not.
Because, see, it's the other way.
No, if I added something here,
And nothing here, that is.
and nothing here, then that's not finite.
Because you can have a bunch.
So there's nothing here, no nodes. Q2 is empty.
So you can have.
So if this is empty,
Mhm.
and this is not empty, that's okay.
Okay.
But this, its children cannot have a child, because this
Yeah,
is
yeah,
not
I get
empty,
it, I
right?
get it.
That's how it's happening.
Mhm.
So if I have empty, not empty half scenario, then that is it, that is all I can think of.
Yeah, so when in this scenario, see, now it is not having any children.
No, not only this is one half, right? Same thing, obviously.
Keep doing
What question
Same
is
thing.
same question.
Same way, trying to solve this thing first.
Using breadth first.
I'm not able to find an answer.
No, so because the problem is that at each level, you know,
I'm trying to see if there's a good way of figuring out, like the way the Uber owner is able to figure out was the left half, the left queue, right? So essentially, you have to tell you, I have my left queue, which contains all the children. I will add null whenever to fill the gaps. I have my right half. I'm saying if I have a scenario where my left half is not empty and has a child, and my right half is all empty, then that is a mismatch, imbalance. I would say imbalance at the root level. Now we have to go further and do it all.
Basically, you have to have tracers,
It won't
different tracers for each level.
That
To
technique is
manifest
good.
that.
So that's not good. Anyone solve this?
Yeah, anyone has solved it or thought more
So
on?
basic,
So what I did was like, I'm calling the height function with left and right, storing in some variable and returning the, depending on the difference, if it is more than true or false. So
Okay,
first
so
I'm checking if root is null.
You want to go and write
Yeah,
the code?
maybe I
on
can
the
write
board?
it. I don't know.
Find another pen.
It's not working.
It is, but I think it's becoming a little lighter from the right.
First I'm checking if this root is null. So it's a balance while returning
You
true.
attempted. But writing it. That's where it gets very confusing. It's not right. You can.
So if it is not null, I'm taking the left tree and right tree.
We have to check left and right are not allowed.
So I'll check later.
Okay.
Uh, just return. I'm taking the absolute value between these two. If this value is greater than 1, then I can return false. Return true here. So I'm just missing, I think, if it is left and right are null.
No, but I think in height function we can check.
Exactly.
So
But-
it's,
Yeah, height will return 0 if it
Yeah,
is null.
So where are you checking the balanced property?
So this is the balance
What
property.
is math absolute?
So absolute value between these two left and right
Okay.
would be child if it is greater
So
than
what
1.
does this function do actually?
should be temp 1 minus
Don't you
temp
have
2.
to like subtract something somewhere?
Math dot subtract.
This is subtract?
Yeah, absolute value is the difference, give the positive difference. If it is like 1 minus
No, you're missing the.
No, the subtraction sign should be
The
there.
comma is not comma, it's a
It's
subtraction.
minus, right?
Math dot app
Yeah.
of A minus B, right?
Yeah, yeah.
You put a comma.
And you don't need the ternary
Yeah, yeah.
operators.
Yeah, now it's fine.
Just return that thing itself, right, or the other way around.
Yeah, yes, they have a check show
Why,
up.
why have a ternary operator?
Yeah, you don't need this.
And just flip the condition, right?
Less than equal to 1.
You flip the condition.
Less than,
If less than
less
2,
equal.
right? Or less than
Yeah,
equal
less than 2 is fine.
1.
Yeah.
Will this work?
Check.
Will this work?
We are not checking the topmost ones level, so there could be something in within the big tree that is
Yeah.
mismatched.
Like this will only work at the
So this is looking at the max level of
at the
left and max
smaller
level of
levels,
right.
but not at the, if the imbalances are the bigger levels,
Mhm.
you know, which are 2 levels apart, then this will not work.
It will, right? Or it will.
So it will miss the case where there's the max
Let's
height
try.
differs by 1, but there could be nodes in between which are of different heights.
So let's give some examples and let's see if this. I'll just give a simple example.
I think this is fine. Only thing it doesn't tell is that at which level the problem is happening, but it gives the
I
answer.
think it will give the answer, right?
No,
Yeah,
but
yeah,
it gives,
yeah.
no, it won't, because it's not, you also need to make sure that your left is also balanced and right is also balanced.
Of every level.
So
So at this
So
point of
this-
time,
it at
if I
every-
give you a tree, which is like 100 nodes on the left, like a linked list, 100 nodes on the right as a linked list,
Yeah.
what do you think is output? Is it balanced or not?
it says it will.
It's not balanced.
It's not balanced.
A tree, which is like, erase everything in the inside, right? V-shaped tree.
Yeah, I got it. I got what it is.
Erase 3s and the 4s on the right. Yeah, just erase all that. And put 3 and 4 on this also, right?
Okay,
Is it
so-
balanced? This is not a balanced tree.
Okay, I
It's
think.
not a balanced
the-
tree.
This is such a balanced tree because the height of left is 4, height of right is 4.
Yeah.
Okay, okay.
That
So
does-
I think, okay, I was just.
Why will it do
just-
that? Because I think when it comes here, it
No,
is
where is it
going-
coming there?
So no, it'll keep going recursively.
But there's no
left.
recursion. Why? Where is the recursion?
Yeah,
There's no
balance-
recursion in the height.
There is no recursion.
Oh, okay. I think I was looking at.
Why is this not balanced?
Yeah, there's no
This is not balanced.
No, so I
Every
think.
level has to be
Okay,
balanced.
okay.
Every node has to be balanced.
Yes.
No, I was
And the max
thinking this
frequency
instead of
one.
height, this is balanced. I think this is where I was.
But then what is it? What is
Yeah,
it?
I don't-
What is it? You can't return an int, right?
So this should be a
No,
helper
so-
function. So you will say this function, whatever tree node is your top function, and you will call another. Let's say this was something balanced, just balanced,
This is fine. Yes.
and then you will call is balanced here with the root, and this is balanced is defined as int.
And how do you
So you-
interpret the return value?
So here you'll have to then, so yes, so you'll have to have, here you'll have to say int, this is because this is what I had written. So int, so I'm actually going to return the height. No, I'm actually going to return value, which says whether it is true or false basically. So, and I'm going to say that if, this is what I had written. So if, so basically this is the value here. And then I'm going to, so instead of saying return math dot, yeah.
I mean-
So you will, so here you will do return. So I'm going to actually write the height function here itself. So I'll say math dot max of and 1 comma and 2 plus 1. So this would be my
Basic. Now,
no. So I have to take the difference before that. Before I return this, I have to do a difference. So let me just do this. So I'll say int difference is equal to temp 1 minus temp 2. This is again an absolute, math absolute. I have the difference here, and then I'm checking if the difference is greater than 1. So for my reference, I had said that a value of -1 indicates that it's not balanced. So else I'm going to just say return math.max of temp1 comma temp2 plus 1. And yeah, so there is one other check here, that the minute the left tree goes out of balance, you can return right here rather than actually going to both the left and the right trees. So you will say if temp1 equal to -1.
-1, okay, just return -1 is okay.
That's something I just assume that it
because
is.
the difference is, you're checking if the difference is greater than 1, right?
Yeah, so but then we are taking the absolute value and then checking the
I understand that, but if your right tree is 0 and your left tree is -1,
What do you mean left tree is -1?
if your left tree is unbalanced, then you're returning a -1, right?
The minute you see there is an imbalance, you'll return a
So,
-1.
the height of my left tree is now -1, correct?
Because you are
Okay,
returning.
so
Okay,
yeah.
so the height of my right tree is 0. Then the difference between my left tree and the right tree is only 1. So it's acceptable. So I would return a -2 at least.
Okay, but
Because
so
that's
what I'm trying to say is the minute I return a -1,
Uh-huh.
I'm going to check if it is -1 and then I will
That's
continue
okay. That is the
returning
left.
to
That's the
-1.
left grandchild you're talking about. So
Okay.
let's assume that you're at some node x, okay,
Yeah.
and that node x has only a left child. Okay, we've got new markers.
Yeah.
See if that works any better.
This is shortcutting. You will not go to the difference.
We'll come to that in 1 second.
Okay.
Okay. Okay, and so that's that node x, right? Leave it at that. And then this node y, which is the second node. Let's assume that that is imbalanced somehow. Okay. So now what happens?
Imbalance below somewhere.
No, this is not that. This tree is not balanced, right?
Okay.
So what will y return? The return from
Yeah,
y will be -1.
Yes.
What is the right is null?
Extra right is null.
Okay.
So that
Okay, there's no.
now
That height is 0.
Flip it the other way around, right? Where it would be this, the left node was 0 and the right was that. Oh, you're checking
Both.
the temp1 is minus,
Yes,
not
-1,
Then
exactly.
Good.
So
we
even
will never
before
go
I,
to the
yes,
difference,
yes,
but-
yes. That's exactly what I was trying
But
to
I
say.
think we can remove that by returning -2. Then we will always.
Then it's always going to be more than that.
So we'll, instead of when there is a difference is greater than 1, we should return -2.
If you do that, the minute the left tree itself is imbalanced, you don't even have to go to right trees. That's what you're cutting short.
No,
here.
but what if the right tree is imbalanced? That is what
You
we
will
are
anyway
saying.
go. If the right tree is imbalanced, you will end up going to the right tree.
And then again, we'll put another if condition to check if temp2 is equal
Of
to
course,
-1,
you will be
check.
putting
Okay.
both.
So
Yeah.
so you can remove both of that condition if you just return -2.
That's what I was trying to get to. It's fine.
But
It's
with
just
this, you will not get out of the function sooner, is what I'm trying to say. Because if
it's an
left was
optimization.
imbalanced,
It's an
then you
optimization
will
that
still
won't help
continue
your
looking at your right, and then you will go down and then you will tell it, oh, you know what, now I'm returning.
Well,
I see.
It is an optimization that will not help your worst case, but it will definitely work.
Yeah.
In a typical scenarios, you'll find answer.
You will find the answer, but then you don't want to go to the
Correct.
not.
Neat.
Okay.
All right. So
Yeah,
question
I'm
two,
sorry.
that-
I when you were writing it, I thought you were writing the same thing. I'm sorry. That was where I got confused. And so you just got the height once, right?
What's the time complexity of that algorithm?
This one
So
is
if you go through- So you're getting the imbalance.
Order of
we are going through all the nodes basically.
Just once?
Oh,
No, n square, right?
no.
No,
Going through
no.
once
This one
only.
we are going each node once only.
Only
Right?
once.
So where's the
Open.
definition of that is balanced which returns an int?
I probably is not
Time
very clear.
complex.
What do you want to know?
So there's the is balance that returns an int, right?
Time complex.
What is the
This is
Every
is
node
balance.
wants
So every node.
O of n. Where n is a number.
and how do you get that int?
Let people think.
This it? How do you get it in the sense?
How do you get that value?
So one is you're returning a -1 here.
Impossible.
The other one is you're returning the difference. It's the height. Either you're returning a -1 or you're returning the height. It's just what I have assumed. You can always change it. And here you're not returning true, you're returning 0. So when you're in the leaf, you're returning 0 and you're telling the height is 0.
Why can't you?
You can definitely improve the case study.
No, can we use a tuple return
You can. Definitely you can do that.
You can have an int in a boolean.
You can do
The
that.
int is actually the height
Correct.
of the subtree.
And the boolean will tell you whether it
indicate
is
whether it's balanced
or not. Yes, yes, you can do that.
And then what we could do is we could return if the difference is less than equal to 1. So that is an indicator of whether that
Boolean
tree
function.
is balanced.
Yes.
Then we also do a Boolean and of whether the left subtree is also balanced and whether the right subtree is also balanced.
Which is
If
the
all
check
three
I'm trying to
conditions
talk
are
about
true-
here, saying -1, which
Yeah,
you're trying
if
to
all
say.
three conditions
Yes.
are true, then you
Do
can.
you need to do a boolean and?
Yeah, so because the requirements are that the node in consideration, we are checking if that is balanced or not.
That is the
We check
condition.
it-
That is the condition you're checking if the is balance returns -1.
Yeah, but
Then-
then, so what we're doing is when we're passing it back up, you pass a tuple of whether its subtrees, the left subtree and right subtree are balanced, and if the difference in the height, max heights of those trees is less than equal to 1, and then you pass it up.
So this what we have done here, based on I think the way I understand is that I understand you can pass the tuple back up and makes it works, but if it is not balanced, then we are returning -1. If it's balanced, then we are returning a tree the height itself. So with that definition, I think you can get away by just using one integer variable.
Okay.
Which it's essentially a complex thing, right? It just the definition itself is taking care of that. If it's not balanced, then I don't really care what the tree's height is.
Yeah.
Correct?
Yeah.
So there's nothing you can do to redeem that, right? If one of the child trees, one of the child subtrees is not balanced, then anyway the root is going to be not balanced. So you don't have to return the height, you just have to return -1.
Yeah.
If you return -1, that's more than adequate. So what's the time complexity? Do we get a time complexity?
It's O of n, right? Why will you?
Well, what
you
is
are
n?
just- N is the number of nodes max. You'll probably visit you'll probably visit all the way till your right end child if it is unbalanced at that point.
N is the number of nodes.
Nodes.
Okay, what is the space complexity?
Space will be like the height, probably the max. You'll end up with the height, right? Because you're just so it's like a stack, right? You're going in and then coming out, and yeah, it's
So
just
what's
a
the
stack.
worst case space complexity?
Worst case space complexity would be the
Order of
whatever
n.
is probably the
O of
longest.
n would be the worst case.
O of n. Why?
It will be like a linked list.
If it's like child of a child of a child of a child of a child and straight just one linked list like thing,
Then
then it's O of n because you have the depth is n.
Yeah.
Right? What is the best case depth for a binary tree of n nodes?
Log n.
Log n.
Yeah.
If
That
it's
is-
well,
it's
it's perfectly
complete
balanced, is
balanced.
that? What is the worst case for a tree of depth of number of nodes?
N.
N. The worst case is n. O of n is
N.
the worst
Yeah.
case space. Fair enough. Okay. Good. Awesome. What's next?
Do you want to go ahead? Because I saw this other question to figure out if given a binary tree whether it satisfies the BST property or no, the binary search tree property or no. I mean, if you guys want to take up that question, we can discuss. I haven't, I have attempted writing the code. I still have the things of how to write it differently, where you can actually send an object back saying that you you will assemble several things and say that, you know what, this is the binary, I mean, it is true, it's a Boolean function and all that.
So,
or
can you
change-
restate the question?
Okay, the question
Let's go with
is,
it. So
the
somebody-
question is, given a binary tree, return true if it satisfies a binary search tree property, return false if it does not satisfy the binary search tree property.
What is the binary search tree?
What is the property, or what is the binary search tree? It means that if given a node, a root or whatever, the entire left subtree will be less than the root and the entire right subtree will be greater than that. So essentially that property applies at every level.
What if it's equal?
So equal is something that's for you
Duplicate
to,
is allowed or not?
Duplicates allowed or not is the question, right? If duplicates allowed, then where do you put that duplicate?
so
Generally, you pick one side.
you pick a side.
Then
So
greater than
yeah.
or equals is
So-
something, or you say less than or equals. You
Yeah.
pick one. It's less than and greater than equals, or it is less than equals and greater than. Pick one.
I mean, okay, let's.
Pick one.
That is right. You
Yeah,
can
pick-
say
pick left.
greater. I mean, probably for me, I would probably put the duplicates on my right because greater than or equal to is what I will do. I mean, probably we just for our purpose will even think that right now there are no duplicates. Just take everything is,
Sure.
because we are just trying to understand if the tree will satisfy the binary search tree property or no.
Does the data type of the binary search tree matter to the question?
Data type of the binary search tree.
Like, is it an int binary search tree? Is it a float binary search tree? Is it a string
Let's keep
binary
it as
search tree? Does it make a
int.
difference?
Let's keep it as int, but you should
Function
know what is the
definition.
natural.
Function definition will change, I guess.
As long as you have a comparative function defined, then you're good to go, right? And as long as it's a comparable entity, you're fine. If it's binary search tree, it's irrelevant as to what the data type is. As long as you have a deterministic way to figure out.
Which is greater than
As in, if A is less than B, then B is greater than A. That's like that property. Like it has to also, like the inverse property should be true. Okay. Right, do you want to maybe just get the
Yeah.
board while folks are writing so that is any of the markers working or they're not?
They are, but I think they are getting lighter.
Place it vertically.
Probably, okay.
Just
This
leave the
way?
markers vertically
This
so that
way?
Yeah.
for now.
Let me try.
The other thing I noticed, like if you write bigger, then you can capture it on the camera a little better.
Now the markers are visible, and I
Do I
haven't
borrow
even-
some from the library?
I just did. Those two are from the library.
Library?
Yeah. Unfortunately, I just got one. I have more money.